We've been talking about the probability of two events. We started off by saying, well, what's the probability of this event or this event? And the way we do that is we add them. What's the probability of A or B? Well, that would be the probability of A plus the probability of B. Now we've been hinting through these videos about the probability of A and B. And we've used it in calculating OR probabilities and conditional probabilities. But now that we've got an equation for conditional probabilities, we're going to use that to come up with an equation for AND probabilities. All right, here's our equation for conditional probabilities. Probability of B, given that A has happened, is going to be probability of A and B divided by the probability of A. If we rearrange this a little bit, then the probability of A and B will be probability of A times the probability of B, given that A has already happened. And here you go. That's the big one. That is the equation for calculating AND probabilities. Let's put it into practice. We have our bag of 20 marbles. We've seen this a few times in the last few videos. Here's the question. If I draw two marbles at random, what's the probability of getting a green and a blue? Well, of those marbles in the bag, we know that 4 of the 20 are green. We also know that 6 of the 20 are blue. But if I draw a green out first, then I only have 19 marbles left, so 6 out of the remaining 19 are blue. So what's the probability of getting a green and a blue? Well, it's going to be probability of getting a green marble times the probability of getting a blue marble, given that we've already got a green. Let's multiply those out, and you get 0.063. That's about a 6.3% chance that reaching in the bag and grabbing two marbles that I get both a green and a blue. Sweet, not too bad, right? Let's apply this in a more complicated example. So you've got a student who goes to the library, and we have some data about students who go to the library. We say that 40% of students who go to the library check out a book. 30% of students who go to the library check out a DVD. Of the students that check out a book, 25% of them check out a DVD. All right, so that first line, basically what we're saying is, if I choose a student at random, what's the probability that they check out a book at the library? 40%. Second line, what's the probability that if I pick a student at random that they check out a DVD? 30%. What's this third line say, though? Of all the students that check out a book, 25% also check out a DVD. Pause the video for a second. See if you can write down the right probability for this one. Okay, I'll answer that question in just a second. I'm not going to do it right now. We'll get to it in just a second. Let's get to the main question. What's the probability that someone gets both a book and a DVD? All right, so here's the equation. Probability of getting a book and a DVD is going to be probability of getting a book times the probability of getting a DVD, given that we already have a book. Well, what's the probability of checking out a book? We already talked about that. That's 40%. What's the probability of getting a DVD, given that we've already checked out a book? Well, hopefully you saw that when I asked you what's this line right here, the third line. Of the students that check out a book, we know that we're looking at just the students who check out a book. Of those students, 25% check out a DVD. That is our conditional probability here. So there we go. Probability of getting a book is 40%. Probability of getting a DVD, given that we've got a book too, is 25% or 0.25. So what's the probability of getting a book and a DVD? We just multiply those together. 40% times 25%, which says that the probability of someone getting both a book and a DVD is 10%. Excellent. Let's go to the next one. What's the probability that someone does not get a DVD if we know that they got a book? Go ahead and pause the video, see if you can figure that one out. Okay, so we're looking at someone who is not getting a DVD, but we know already that they got a book, which means we're dealing with the same group of the students that check out a book. 25% got a DVD, so how many did not get a DVD? Here we just take a complement. So the probability of not getting a DVD, given that they got a book, it's just going to be the complement. 1 minus 25%, which is 75%. That's the rest of the group. 25% of the people who got a book got a DVD. The other 75% did not get a DVD. Excellent, excellent. Now let's use that in our last question of this video. What's the probability that someone gets a book but not a DVD? So this would be the probability of book and not DVD. And so from our equation, that would be probability of checking out a book times the probability of not checking out a DVD, given that they got a book. All right, so we know that the probability of getting a book is 40%, and the probability of not checking out a DVD, given that they checked out a book, is 75%. Multiply those two together. The probability of getting a book and not a DVD is 30%. There you go. There are a few examples of how to use and probabilities. We got a little deeper into this last example, looking at complements and the such. It's a little more realistic of an example, though. So there you go. And probabilities. Now, there's one last thing we need to talk about in this lesson, and that is independent events. And that will be the topic of our next video.